Okay, so we're live.
Right. And then like right after the high place or whatever, you take a right, go over it, and then you take a right after that, and there's a loop on the back side of it.
Okay.
Yeah, Kayla doesn't know she's going back to work tomorrow, so I don't know if I'll have a job.
10, 15 hours, I think we're 30 hours a week.
So question 1. When a cold alcohol thermometer is placed in a hot liquid, the column of
I work every day.
goes down versus up. Why does it?
I said that so like the initial like the thermostat itself, because of the heat, it'll expand, right, which will cause the mercury of the alcohol to like go lower. But then as the alcohol itself is heated up, that will expand and pull it up and go up.
Yeah.
Yeah.
Yep.
Yeah, the glass.
I will.
It expands quicker, making the
Laptop. Make sure to grab my shoe real quick.
Yep. It's very brief.
Today's just a wonderful day.
Two, how expansion gap should be left between the still railroad. They reach the maximum temperature, 35 centigrade, than when they were loaded. The original length is 10 meters. I got 0.00 meters.
4.2?
Yeah.
Yeah.
4.2 e to the 3. Yep. Negative 3.
Cool. Okay, number 3. An expensive vacuum system achieve pressure as low as 1.10 to the -7 newtons per meter squared at 20 centigrade. How many atoms in a cubic centimeter at this pressure? Got 2.47 times 27.
Sweet.
What's the gauge? So number 4. What's the gauge pressure at 25 centigrade? Car tire contains 3.6 moles of gas at 30-liter volume. So I got 297.3 meters per meter squared.
I got 2.84 ATM.
I got 1.94.
Is that for B though? 1.94. I got 1.94. I don't know if I like accidentally swapped something or something.
For B, I got 1.97.
George, what'd you get?
So for 4A, I got 1.94 ATM. And then I got 0.0409 moles for B.
Yes. Different answers. So it's probably the 1.94 for A.
Is A. Yeah, because that's several people got that. So the B.
The equation that I use, so like the change in moles is equal to PV over RT. All right, so the pressure, the volume, that's 1 divided by, and then R 0.082, and then T 298.15.
I think you're right, George.
But I don't know.
Should we just go with that?
Yep.
And B, let's do it.
Let's go with George's. Okay. So number 5, hydrogen molecules molecular mass equal to 2.016 grams per mole have an average velocity equal to 1.93 meters per second. What is the temperature?
I got 3.01 Kelvin.
That's what I got.
Good. Yeah, that one I got a huge number and it's totally wrong. I knew it was. Okay, number 6. What are 3 factors affect the heat transfer that is necessary to change an object's temperature? So, pressure and the mass and
the phase of what is
substance and phase of substance.
solid,
yeah.
gas.
Cool. If you place 0 centigrade ice into 0 centigrade water in an insulated container, what will happen? Will some ice melt? Will more water freeze? Or will neither take place?
Nothing.
Yeah. Because at the rate that the water's freezing, the ice is melting. So it's the exact same.
Yeah.
And it's equilibrium. If you pour 0.01 kilograms of 20 centigrade water into a 1.2 kilogram block of ice, which is initially at 15 centigrade, what is the final temperature? You may assume that the water cools so rapidly that the effects of the surroundings are negligible. It's like a -1, negative 13.2 centigrade.
I got 3.76 e to the 4th joules. What did you guys get?
I didn't do that one.
Yeah, that was the only one I didn't do. Oh, man.
I got it in joules, mine's wrong.
So we'll look this one up. And that's right here. That's where I got it from.
Sweet.
Yeah.
That's right to me.
Yep. So that one I just totally looked up online, guys. And it's like the exact same problem. Oh, where are you? So, okay. And then number 9, during heavy exercise, the body pumps 2 liters of blood per minute to the surface. Where is it cooled by 2, or where it is cooled by 2 centigrade? What is the rate of heat transfer from this forced convection alone, assuming the blood has the same specific heat as the water and its density is 1,500 kilograms per meter cubed? So I got 293.02, or wait, what? 293,100 or 0. Gosh, 293,020 grams per second, joules per second. What'd you guys get?
I got 293 joules per second.
Yeah, I got 293.
293. Cool. Sweet. Michael's just taking a call, but that was it. So.
Sweet.
So I think George was you had all the right ones, right?
Yeah, I didn't have number 8 though. I didn't.
Okay.
That's the one I didn't do number 8.
So I'll just on the email, I'll just send like the link to where I got it from.
Okay.
And you can just copy it down and then just submit yours for the group work.
Yeah.
That works.
So wait, what was 9?
Cool. So 9 was 293
Oh, sweet.
joules.
Sounds good.
Okay.
Cool beans.
All right.
Well,